Okay, thank you. Hello, everyone. Welcome to FOCIL Breakout 21st. Today we have a research presentation. Luca from L to Bit will gonna give us a talk about FOCIL on native rollups. A native rollup is an EVM-based rollup using the execute precompile, so you can minimize the risk of bug, governance, and so on and so forth. For anyone interested, please take a look into this article. Let me share it in the chat. After the talk, we can share development updates as usual. So please welcome Luca from L2Bit. Luca, if you're ready, the stage is yours.
Hey everyone, thank you for inviting me. So I don't have slides because I was in Singapore last week and didn't have the time, but maybe it's even more interesting this way. So I can maybe share let me see, that website that you shared in the chat. And what I want to do is let me see, is to give you kind of a small introduction on native rollups, the idea behind native rollups, and why I think that FOCIL is very useful here, especially for native rollups, but not only. So the idea behind native rollups is, so let's assume, first of all, that we have statelessness on L1, so we can execute transactions, we can perform the state transition function L1 without having the full state. So we just have a pre-state root, we have a post-state root, and we have a list of transactions, which are possibly, stateless traces to be able to. And now the idea here is if L1 full nodes can perform a state transition function which is stateless, in principle, they can perform the state transition function on arbitrary states, not only the state of L1. So in principle, these L1 full nodes can apply the state transition function with the state of the rollups as well, right? And if done, naively with re-execution, it doesn't bring many benefits because you would consume the same resources. But if we also assume that we have ZK on L1, this becomes much more interesting, right? So the idea behind native rollups is to reuse the same stack that is used for Ethereum itself, but for the rollups as well. So the goal of the native rollups proposal is to implement a precompile, which is called the execute precompile, what it does is basically a recursive function to the state transition function. I have two variants in my documents. One that does a recursive call just to the apply body. I assume that you are familiar with what I'm talking about in the execution layer, given that FOCIL touches this stuff. So one variant only does a recursive call to apply body. It skips the header checks. While the other variant does, it's a recursive call to the state transition function with all the header information. So this is a little bit more, is a little bit longer, while the other one is a little bit shorter. And the reason why we have both, because a lot of rollups today, they skip header checks in the first place. So it's interesting to have both. In any case, the idea here is the execute precompile takes as an input all the information that goes in the block environment that is then used in the block environment, of course, and the transactions, right? So an input is the list of transactions, which is ideally a link to a blob or many blobs. And then all the information that is usually required for this block environment. So for example, the chain ID, this is specific to each rollup. This is an input. The pre-state, this is supposed to be saved in a contract on L1, and you pass it again as an input. You can have arbitrary guess limits. You can have arbitrary Coinbase. This could be, a predefined address. It could be set to be the same as the L1 Coinbase if you're, for example, a base rollup. And in general, all these values can be inputs. And these inputs are then passed to the apply body, which does the actual transition and checks that the transition from a pre-state, which is again a state root, and a post-state is correct, using the same execution environment that Ethereum already uses. And the cool, a cool way to read is the same relation that there is between the consensus layer and the execution layer for Ethereum. The same relation can be found between L1 and L2 in the sense of, for example, the block guess limit. No, sorry. Like the Coinbase is an information that comes from the consensus layer, right? Like all the information that comes from the consensus layer now comes from L1 from the perspective of a native rollup. So another like obvious example is Randao, right? This is something that comes from the consensus layer. For native rollups, this is an input that comes from L1. And L1 can decide whether to like either pass the things from the consensus layer or do something else. And this is quite cool because now you kind of have a programmable consensus layer in the form of a smart contracts, which is super interesting. So this is the like short TLDR about native rollups, and the important thing about this precompile is, okay, we want to do this recursive call so that, the reason why we want to have this recursive call, by the way, is twofold. First reason is we want projects to upgrade every time Ethereum upgrades automatically. So if this, if there is a fork, this changes because there is a new instruction, a new precompile, then it is also a new transaction type, let's say 7702. They would also be automatically supported on the native rollups as well. So these rollups wouldn't need to have their own dedicated governance just to have feature parity with one. And the second reason is to be bug free, because if there is a bug in a native rollup, it also means that there is a bug on L1 and it's going to be fixed with a fork. This is not what happens today if there is a bug in a rollup. If there is a bug, then L1 is not going to save them. So, so we want to do this recursive call, but the thing is the L2 environment is a little bit different compared to L1. It's not enough to do this naively. And that's why like there are other things around. Not many, because again, we can say that it's very short. We need some things. So for example, one thing that needs to be supported is messaging from L1 to L2. And I have this page that describes the way that current system works, like at least popular ones or like most interesting ones or unique, like OP-Stack, Lineattack, and Orbistack, how they implement L1 to L2 messaging. Which is used for deposits, token deposits from L1. You deposit a token on L1, it needs to appear on the L2, and then you need to implement withdrawals from L2 to L1, right? So, a messaging system that, for example, is able to burn those tokens on L2 and unlock the tokens that are locked in an escrow on L1. And one of those differences from L1 execution environment and the L2 execution environment is forced transactions. So we really want rollups to have the same censorship resistance as L1, as Ethereum. And this means that if, for example, you have a rollup that has a centralized sequencer and the centralized sequencer is censoring you, you should be able to send your transaction on L1 and have the guarantee that if L1 includes your transaction, then also the L2 will process such transaction. And I work at L2Bit, and one of the most difficult things to implement for a project is forced transactions. They're very complicated. Every project kind of has a different way to implement forced transactions. For example, if you look at OPStack, they have a new transaction type. This transaction type is called a deposited transaction, and they need to heavily modify how the derivation works. I can show maybe like in the derivation, if you look at this is the OP spec, when they derive the transaction list, like it's quite complicated. Of course, I will not go into the details, but they kind of significantly modify the L1 execution environment to be able to support forced transactions. If you look at Arbitrum, the way that Arbitrum implements forced transactions, it is even more complicated. They have not one new transaction type, but they have many, these many. And there are projects that try to minimize the diff with L1. So one example is Linea. Linea is a project that wants to be an L2 without touching the execution clients at all, right? And because of this, they have been particularly struggling with implementing forced transactions. Because L1, again, doesn't have a concept of forced transactions. And we talked with them for a long time. They presented us with a doc, with a proposal for forced transactions. And basically, the simpler way you can implement forced transactions today in a system is to, like with a centralized sequencer, is to have some windows, some periodic windows where anyone can sequence transactions. So basically you have these windows where you become a base rollup. Linea calls this block base blocks. So every now and then there can be a base block, which is problematic because if you, for a certain period, you're based, you get into all the complexity of being based, of having base sequencing for pre-confirmations, and the UX is not great in general. And we also talked with Aztec, which is this privacy L2, and also for them, it has been like they're not TVM, but also for them it has been like quite challenging to implement forced transaction mechanism, and they also are planning to maybe use these base windows. But then, in any case, the message that I want to send you is implementing forced transaction is very difficult. And so if we want to implement forced transaction for a native rollup, what is that we would need to do? Either we go with these base windows, but again, the UX is terrible. I don't think anyone really would want to do this if there is another way. The other way is that, so the high level idea of forced transactions is the sequencer is answering you. You send a transaction on L1. On L1, you have a smart contract that queues these transactions, right? And then you need to have a mechanism on L1 such that you take the sequencer batches, the list of transactions that the sequencer wants to post. You take this forced transaction queue on L1, where anyone can just push transactions to this queue. And then you need to have a mechanism to check that the sequencer actually includes the transactions that are in the forced transactions, right? So this might sound familiar. Basically, the first transaction queue works as an inclusion list, and you want to force the inclusion list in the sequencer batches. And to do this, it is difficult. Like most of the time, this is done as part of the derivation, or like in general, this is done as part of the state transition. This is not a check that is on L1, because checking that some transactions that you have saved, let's say in storage on L1, are included in a blob, because the sequencer on L2 posts stuff in a blob, probably requires a ZK verifier. And the purpose of native rollups is that we want to simplify managing a rollup at a point in which projects do not even need to think about ZK verifiers, right? So this is a problem. So I was looking at FOCIL, and the cool thing about FOCIL is that it implements exactly this mechanism from an execution layer perspective. So I'm not looking at the consensus layer at all, because it doesn't matter for native rollups, in the sense of the consensus layer, everything that L1 fetches from the consensus layer, and a native rollup would fetch from a contract on L1. So if I looked at the spec, again, I'm not super familiar, but my understanding of the spec is there is this new inclusion list that is added to the state transition, and then there is this validate inclusion list transactions, I think, which does exactly the thing that force transactions are supposed to do. You have the list of transactions that comes from the builder. You have the inclusion list that comes from somewhere else. And then there is this piece of code that checks that the transactions that come from the builder include the inclusion list transactions, right? So now, if we have this on L1, all compile would be able to make use of it. So if we go, this is the execute precompile. At some point, the execute precompile would do a state transition call with a blockchain in a block. If we have FOCIL on L1, here we would add an inclusion list. And these inclusion lists would come from a smart contract. So again, the idea here is there is some function that allows user to send transactions on L1. These transactions with the full signatures are saved in the smart contract, and then this list is passed as an input to the execute precompile, so that the state transition of the rollup is conditioned based on these inclusion lists. And this would allow to implement first transactions without having to worry about a dedicated mechanism to check for inclusion. So I talked about checking the inclusion in a blob. This is not something that FOCIL handles today or is supposed to handle. But I'm kind of thinking in the future, because when Ethereum will move to ZK, the idea here is that L1 itself will also post its transactions to blobs. So FOCIL in a ZK world also kind of needs to check inclusion within blobs. This is like a future problem, open problem, whatever. But like I'm assuming that L1 will fix FOCIL with blobs by itself eventually, and native rollups will be able to use the exact same mechanism for this. So I think I can stop here if anyone has questions.
Great, thank you, Luca. Uh, you've covered uh, what native rollups are, challenges of implementing forced transactions for rollups with centralized sequencers, and how can we add forced transactions to native rollups. If I understood correctly, I think the main idea is to use the inclusion list transactions field of state transition function to enforce the forced transactions. And those will come from a smart contract, and any user can send and save transactions to the smart contract, whichever they want to enforce, right?
Yes, yeah, exactly. So the thing that I still need to figure out, and that maybe you guys can help, is um, how to handle the complexities of sending transactions to a smart contract compared to the mempool, right? Because it could be that you send a transaction to inclusion lists. These are used as an input to the state transition, but these transactions don't actually get in because of gas limits or whatever, right? So um, there is a problem of like resubmission because uh, it could be that they don't like we don't have a mempool that keeps the transactions. These transactions are actually consumed. So this is kind of the complexity that needs to be solved. But I'm pretty confident, like I'm pretty optimistic that they can be solved. Also because um, existing rollups already have this problem in a way or the other with first transactions.
So as long as we somehow have the transaction included in a block, it's okay, right? As long as the transaction has have no problem um, when when it interacts with a smart contract. Like there is no like revert, no. If that execution goes okay, then all we need to care is whether the transaction is included in the block.
Yeah. Like what I'm worried about is, let's say um, a transaction is at the tip of this queue, right? Uh, it is um, it is used as an input of the state transition recursive call, like as an inclusion list. But then the transaction is skipped. I don't remember exactly where this is done. Uh, like, where is it? Here, right? Uh, where does this continue in the spec? What
Oh,
happens if a transaction is skipped? You will need to resubmit the transaction on L1 in this queue.
um,
Uh,
so yeah, that part is so you can see to continue here. The first one is to check if the IL transaction is not a blob transaction, because currently we don't support blob transaction
right,
because
yeah, that's fine.
yes, because of some possible other factor. And the second one is actually is it checks if the not included IL transaction could have been appended at the end of the block. So what we want is if an IL transaction is not included, then we are executing lines below 1110, And
Yep,
if we are hitting that line, then we want to see if the IL transaction cannot be appended at the end of a block. So when we try to validate and execute a transaction at the end of a block, if we have any kind of a exception, then that's fine. That IL transaction is validly omitted.
yep.
So that's what the code is trying to achieve. And ah, right. I guess you're saying that there could be a possible cases that a forced transaction can be validly omitted for some reason.
Yeah, exactly. Like what happens in that case?
Mm,
In FOCIL, in normal FOCIL, I think it would remain in the mempool, right? And can be picked again, I would assume. In this case, you probably would need to resubmit your transaction on L1.
I guess it depends if the transaction cannot be included in subsequent blocks for whatever reason, then the transaction will be evicted from the mempool. Otherwise, I think includers will pick it up again in the next IL, just as Potas said.
Yeah, exactly. So like this is kind of the difference that needs to be thought a little bit more in the context of native rollups.
Yes.
How to handle like resubmission. But again, as I said, I'm pretty optimistic that there is a solution somewhere.
Do we have a similar cases today with forced transactions?
So like the only case, I don't think there is, because so for optimism, the way that in OP-Stack works is there is kind of always space for first transactions. They always allocate some space just for them. So
So Luca, you shared some challenges that L2s are having to implement forced. If we somehow succeed to have FOSIL in L1, then it'll be good.
like L2s could already implement FOSIL even without having it on L1, right? So in the sense of like if their goal is just to have a FOSIL-like mechanism, they can already implement it. If their goal is to minimize the diff with L1, which is what most projects want, then of course you need to wait for all core devs calls. This happened many times that someone wanted to have something on L1 just to have it on L2s as well. And my feeling is that this is not a strong enough argument for something to be included on L1. But
To L2. But yeah, when we are considering some feature for L1, then we should prioritize L1 over L2. So yeah, that's a good point. Potas, do you wanna share
Yeah,
something?
what does it mean FOSIL on L2? L2 doesn't have for choice. So what part of FOSIL or
yeah. So the idea here is to
that is an implementation detail. It's not a mechanism. Simply reusing that part of code in the EL.
the check that the sequencer batches include first transactions. It is difficult for rollups without heavily or like significantly modifying L1. And the idea here is if the execution layer already has this check, the rollups can reuse this.
Yeah,
and
but
by the way,
you're really
for
assuming
rollup,
that the check is going to be the same. You're assuming one condition on rollups that rollups are going to conditions on being includable very different than being includable for L1. They might depend on different things.
Derivation a little bit. And for native rollups, we cannot have dedicated transaction types just for first transactions. So how can we implement first transactions without new transaction types and without doing crazy things? The simplest thing is to, like if L1 already has a mechanism for first transactions, more or less on the execution layer, the native rollups that the only thing that they do is a recursive call to the saturation function, they would be able to reuse the same exact mechanism. And of course, this restricts the design space for first transactions a lot. that does, I don't know, the check in a different way. But the cool thing about the inclusion list being an input to the execute precompile is that, for example, you can implement delays, right? So you can pass, for example, let's imagine that this inclusion list is a queue on L1 in a smart contract. You can have a delay of, let's say, 12 hours or 24 hours before these transactions actually are actually fed in the execute precompile. And but yes, like I agree that this limits the design space. But native rollups are supposed to be very, very similar to L1s. And I don't think, from a user perspective, it makes a lot of difference.
Great. Maybe we can have one more question if anyone has any. Otherwise, we can move on to the next topic because we have only 20 minutes left. All right, thank you for your presentation, Luca, and thank you for all the Q&A. And if anyone pop up with another question, then just feel free to ask him in the chat. Yeah, so for development updates, does anyone want to share some updates? Maybe I can go first. I'm currently adding some unit tests for inclusion list to store. And then I'm gonna share a document that lays out test cases. It won't be exhaustive from day one, so please feel free to contribute. I haven't started it yet, but it would look like this. So I'm not sure where to put this. I'm gonna ask Justin about this. It may be placed under FOCIL for implementer repo or consensus spec repo if it's possible. Not sure yet, but yeah, that's what I'm working on at the moment. Does any client have any development updates?
But I don't see on the CL side what's the issue.
But you don't see such error when you are working with other features, right? Like we don't have such error in Holaski DevNet, for example. So I think there's something wrong with the get prototype, I guess. So I rebased it actually last week, but I haven't
which I'm not sure where the issue is. There's one issue I know about in Loadstar that we use the same cutoff for attestation view freeze and proposer cutoff. But I don't think that matters in a local DevNet. It should be available before the attester cutoff anyway.
That should be fixed now, though. There's a bug in just some encoding for the ILs and how we were reading it from the engine API. But in recent tests, I haven't seen any missed blocks from unsatisfied ILs. So definitely check the newest commit.
I said, do you have an image public from if Panda?
I do not have an image up right now. To get the metrics working, there's some issues with like how Reth does metrics that I'm looking into right now, but we have some basic metrics up, and then we're also looking at.
We bumped into the problem that how to count invalid. For example, it depends on implementation, like they're not invalid. So I wonder how other clients implement this. So really count invalid transactions in this case. This new list of transactions like valid and invalid size bytes, gas usage limit. Is it possible to count? A little bit tricky to count. invalid transactions in this case. I don't know, Jihun, how it is implemented on the guest side, maybe you know. How it is implemented on the guest side, maybe you know, or we may discuss.
Yeah, so on the CL side, transactions are just bytes. So they don't, interpret what the transaction is. That's why we just care about enclosure list too much. Then yeah, we can just decide to not add new metrics. But on the get end, so there's a code that checks if there is a leftover enough gas left to add any missing IL transaction. So we could use the code to log whether too many metrics, and we can, just trim it out and leave it with only necessary ones.
Yeah, I don't mind any additional transactions. Just I want to be sure that other clients, because I think for Pele, he had to change the code to count invalid transactions. So maybe he can add as well, like more on this.
Yes, Pele?
Yeah, sorry, I think there was a little bit of a misunderstanding. When we were first talking, I was thinking invalid as in transactions that make the block invalid, not like invalid transactions because of gas and whatnot. So it's not really a worry, Kaya. But we should be sorry about that. Yeah.
Yeah, and I wonder if
To other topics.
No, I don't think so. It looks quite good. I started to build a dashboard like CL and DL parts separately, but now I'm thinking of that it's better to combine, for example, the metrics regarding payload. It's better to combine them on one panel maybe, and to easily compare CL and DL part correlate with each other.
But do you think it's better to
right? So you can see both EL and CL for the similar metrics. Let's say how many transactions sent and how many transactions received. So for these metrics, maybe it makes sense to put them together. Whenever it will be finished on the REST side, I will share the whole dashboard, the whole picture, and we can just.
Yeah, we can continue discussion regarding it. Do we have any other updates? All right.
Quick question about same v5 for FOCIL, or it depends if it will be SFI for FOCIL, or it depends if it will be SFI'd or
merge those two changes into one v5. And yeah, so if the bell is already there, so I think it has priority. So if we decide to not include FOCIL in Amsterdam, and somehow, let's say we want to add it in H fork, then we want to.
Got it. Thank you.
Yep. Thanks. All right. Otherwise, we can go ahead and wrap up this call and have another call after 2 weeks. All right, then. Thanks for joining and have a great rest of your day, and see you guys in 2 weeks.
Thank you. Bye.
Thanks.
Goodbye.
Yeah.
Bye bye.